All right, Diamondbacks, it's Miss Hillman and Miss Castro here again with you for number 4. All right, Antoine and Angela, A and A, that's what we're going with. A and A both like to walk for exercise. Today they will walk together. Antoine walks 3 days. Angela walks every 5 days. Check all the days on which they will walk together again.
All right. Keywords again. You know it's going to be multiples.
Yep.
Again, the same day.
Again. And then all the days as well. Because we also have that other featured word, all. All right. So we have Anton who walks every 3 days. So let's write those multiples. It'd be 3, 6, 9, 12, 15. And do we have any numbers going higher? We do. 15, 18. We have 21. I'm going to keep going. 24, 27, 30, 33, 36. It keeps going. All the way to 45. I'm giving you a hint there. All the way to 45. And now we're going to count by fives. Hopefully at this point you're thinking, I know 5 only goes evenly into 5 numbers that end in a 5 and numbers that end in a 0. So that should help you know.
So you know that 8 cannot even be a possibility.
Yep, so 8's not even it. So we'll just take that off. 12 either.
Same.
All right. From here, we only have 15, 25, and 45. We know 5 goes into each. Right now I'm just willing to look and see, can I work smarter, not harder? So looking here, I know 3 does go into 15, so that would be 1. And we already have 45. That would be another. Noting that 25 comes between 24 and 17, and it's not one of our multiples of 3. So my only answers would be 15 and 45.
Yeah. Woohoo! All the days they'll walk together.
Yep.
Good job, A&A.
All right, going to number 5. What is the greatest common factor of 36 and 42? All right. You like to do the U shape? Mm-hmm. I haven't done the U shape, so I'm going to watch.
Okay. What do you do, tree factor?
Yeah, factor tree.
Factor tree, yeah. My kids like a little bit of both, so we could even show both if you guys want. So if we have 36 and we have 42, think about all the factors that go into 36, but don't jump around, otherwise you'll miss some. So go in order. Does 1, of course, 1 times 36. Does 2? Yes, because it's even. 2 times 18. Does 3? Yes, I know that. It's 12. But if you don't, just take 36 and divide it by 3. Does 4? Yes, I know that the partner is 9. If you don't know, take 36 and divide it by 4. Take 36, divide it by 5. Or don't bother because you know it's not going to be. It doesn't end in 5 or 0. Go through 6. I know the partner, but if you don't, take 36, divide it by 6. It will tell you the partner. 6 times 6. Go through 7, 8. You don't need to because the partner's right next to it, so you're donezo. 42. 1 times 42. 2 times 21. I just knew that by looking here, but if you don't, take 42, divide by 2. 3 is a yes because 4 plus 2 is 6, which is a multiple of 3, so 42 is a multiple of 3. So 3 times, might have to write it out. That's okay. I'm not going to use my calculator. I'm just going to go real quickly. Oh, it's 14. 3 times 14 is 42. Check it if you don't believe me. Get your calculator. 4 into 42, no, because 4 times 10 is 40. 4 times 11 is 44. 5, no. 6, yes. Partner 7. 6 times 7 is already there, so I'm done. Common, 1, 1. 2, 2. 3, 3. 6, 6. 6, 7, 9. Nothing else is common. These do not share anything else in common except the ones that I have underlined. What's the greatest of these? Love. Just kidding. 6 is the GCF. So we would already have that ahead of time. And then we just look here and we put it here, making it easy on the person to grade. If you want to see the factor trees, here's another way to do it.
All right. For the factor tree, you can use any numbers that you know multiply up to 36. So if you, other than 1, because you know 1 doesn't help us. All right, let's go with 2 times 18. 2 is prime, so we stop there. Next, 18 is not. So we're looking for what times what gives us 18. And that would be 2 times 9. Again, 2 is prime, so we get to stop there. 9 is not, so you keep going. 3 times 3 gives you 9, so we end up with 3 times 3. 3 is prime, so we're done with that one. So listing our prime factors for 36. So the numbers that multiply together to give us 36. We have 2 times 2 times 3 times 3. All right, with our next one for 42. What times what gives us 42? You can use any factors other than 1 because 1 doesn't help you again. So we can use 6 times 7. Lucky for us, 7 is prime. 6 is not, so you keep going. 2 times 3 gives you 6. Both are prime, so we're stopping there. So for 42, the prime numbers you multiply together to give you 42 would be 2 times 3 times 7. And we're looking for, again, what do they have in common? The 2's and a 3. So we simply do 2 times 3, and once again, you get back to 6.